One importance of electrochemical series is that it is used to predict if a displacement reaction is possible or not. For instance, look at the two reactions. The first reaction is possible because sodium is more reactive than hydrogen. So, sodium can displace hydrogen from its compound to form sodium oxide, and hydrogen goes as hydrogen gas. But here, mercury cannot displace hydrogen from its compound because mercury is less reactive than hydrogen. And that is why formation of mercury oxide is impossible. That is why this reaction is not feasible. So it's not only about displacing hydrogen from its compound. A metal can displace another metal from its compound based on their position on the electrochemical series. It is just like a hierarchy. A metal that is above the other will displace it, and vice versa. A metal that is below the other cannot displace it. So now, how do we remember the electrochemical series? We use this acronym to remember the electrochemical series of metals. PSC mazit PH could make silver and gold. PSC mazit PH could make silver and gold. So this is what the acronym means. PSC mazit PH could make silver and gold. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. Hydrogen is not a metal, but it is purposely placed here as a reference. And also, water being a universal solvent, most of these chemicals react in water. So they are there to compete with hydrogen component of water. That is why hydrogen is placed here. Copper, mercury, silver, and gold. So that is how their reactivity is arranged. This is decrease in reactivity. That is why this series is also called activity series. Potassium is more reactive than sodium, which means it is more eager to give out electron than sodium can. And it continues like that. And the least reactive is gold. Which of these reactions is feasible? Calcium reacting with hydrogen chloride or hydrochloric acid. What you should consider is this hydrogen and calcium here. Which one can displace each other? So calcium and hydrogen, what are their relative positions? Is calcium up above hydrogen or hydrogen above calcium? You'll see that this is where hydrogen is. Look at hydrogen here and look at where calcium is. You see that calcium can easily displace hydrogen. Therefore, the reaction number A is feasible. Where calcium will come in here, calcium chloride, because of the +2 charge, chlorine 1-, so calcium chloride looks like this, plus hydrogen will not come out as H, it will come out as H2, hydrogen gas. So you write 2 here to balance it. So this reaction is feasible. The reaction is feasible. But is this one feasible? Hydrogen and sodium. You see that hydrogen is down there, sodium is up there. So hydrogen cannot displace sodium. Rather, sodium can displace hydrogen. But sodium is already in a compound. Hydrogen coming in to displace it is impossible. So the reaction is not feasible. Copper and iron. Look at where copper is down here. And look at where iron is up there. So copper cannot displace iron. The reaction is not possible. Unless you write Fe, solid, plus CuS. You can now say that iron can displace copper because iron is more reactive than copper. So that you have Fes plus Cu.